Many customers become concerned when they first learn that electron beam welding machines generate radiation, worrying that routine operation may pose health risks. Today, based on Bingpeng Technology's hands-on experience in equipment development, manufacturing, and factory acceptance testing, we will provide a comprehensive overview of radiation safety. We will cover the fundamental physics of X-ray generation, the key factors affecting radiation intensity, potential biological effects under unshielded exposure, the multi-layer radiation protection system integrated into our equipment, applicable national and international safety standards, and our rigorous factory radiation leakage testing procedure. Through this presentation, we aim to address the radiation safety concerns that matter most in the industry and provide a clear understanding of the safety measures used in electron beam welding equipment. X-ray generation during electron beam welding is an inherent physical phenomenon known as bremsstrahling or braking radiation. The high-voltage electron gun accelerates electrons to high speeds, with accelerating voltage up to 150 kV. When these electrons strike the workpiece, they are rapidly decelerated by the atomic nuclei. According to energy conservation, part of their kinetic energy is converted into heat to melt the base metal, while the remainder is released as X-ray radiation. Radiation dose rate and penetration are mainly determined by three factors: accelerating voltage, beam current, and material atomic number. Higher accelerating voltage produces more penetrating X-rays, while higher beam current increases radiation output. High Z materials such as tungsten, titanium, and stainless steel generate stronger radiation, whereas aluminum and magnesium alloys produce significantly lower levels. Bingpeng designs shielding thickness according to electron gun power and the materials being processed, covering worst-case welding conditions. The effects discussed here apply only to extreme conditions involving completely unshielded equipment and direct X-ray exposure. They do not occur during normal operation of properly shielded equipment. X-rays are ionizing radiation capable of damaging cellular DNA. High-dose exposure may cause acute radiation sickness, while long-term exposure above permissible limits may increase the risk of cellular and genetic damage. Therefore, reliable radiation shielding is an essential safety feature of electron beam welding equipment. Bingpeng equipment uses a heavy-duty integrated physical shielding structure as its primary safety barrier. The vacuum chamber is made of reinforced steel, with additional lead shielding for high-voltage models operating at 100 kV and above to attenuate high-energy X-rays. The viewing window uses specially manufactured radiation shielding lead glass containing a high concentration of lead oxide, effectively preventing X-ray transmission and allowing safe observation of the welding process. Steel and lead shielding alone are not sufficient, as gaps and interfaces can become potential radiation leakage pads. Bingpeng therefore uses a labyrinth-type overlapping sealing structure at the chamber door, sensor interfaces, and cable feed-throughs. This structure repeatedly intercepts and absorbs X-rays, preventing leakage through the enclosure. The equipment also incorporates a safety interlock system. If the chamber door is not fully locked, the vacuum level is below the required condition, or the radiation monitor triggers an alarm, the high-voltage circuit is physically disconnected, preventing electron beam generation and eliminating radiation hazards at the source. National and international standards establish mandatory limits for X-ray leakage from industrial electron beam welding equipment. GB or T-25778-010 specifies that the X-ray leakage dose rate at any accessible position 5 cm from the equipment surface shall not exceed 2.5 SVH. For high-end aerospace manufacturing, ISO 14744-1 may also be used as an equipment acceptance reference. For comparison, cosmic radiation during long-haul flights is approximately 3-5 SVH at cruising altitude. Compliant Bingpeng equipment can therefore provide radiation exposure even lower than that experienced during air travel. Every machine undergoes radiation safety acceptance testing before delivery, with complete compliance documentation provided. Before shipment, Every Bingpeng electron beam welding machine undergoes a complete X-ray leakage test in accordance with industrial radiation testing requirements. Professional ionization chamber type or NICE scintillation type radiation survey meters are used. Before testing, the instrument is warmed up, the battery is checked, and ambient background radiation is measured, typically 0.1–0.2 SVH. Testing is performed under worst-case conditions, with the accelerating voltage at full rated value, beam current at the maximum commonly used level, and high-Z targets such as tungsten or stainless steel inside the chamber to generate maximum bremsstrahling radiation. During scanning, the probe is maintained 5 cm from the equipment surface at approximately 5–10 cm per second. 4 critical leakage points are carefully inspected: the lead glass and door frame joint, chamber door O-ring seal, electron gun high voltage cable flange, and vacuum pump interface. Each point is monitored for 3–5 seconds. If the dose rate approaches or exceeds 2.5 SVH, the high voltage supply is immediately shut down. After any repair, the complete test is repeated. Radiation survey meters must also be calibrated annually, and all test records are properly archived. X-ray generation is an inherent byproduct of electron beam welding and cannot be completely eliminated. However, Bingpeng equipment combines heavy metal shielding, labyrinth sealing, electrical safety interlocks, stringent safety standards, and full machine radiation testing under worst-case conditions to keep X-ray leakage within a very low and controlled range. Hejiang Bingpeng automation technology provides more than electron beam welding equipment. We offer one-stop welding solutions, including radiation safety compliance support, annual radiation ray testing, and operator safety training, helping customers achieve long-term safe and compliant production.